Please do ask questions as we move along. And hopefully it will fit within the hour. Alrighty, so from my point of view, a little bit about myself very briefly. I've been around this business more years than I care to admit. I started in the late 60s. Been working all with that with CICS. I started with CICS OS Standard 1.0. Done both applications and systems, so feel free. But I also work with DB2. We have DB2 11 and 12 on our system. CICS 5.3, hopefully soon to be 5.4. All right, so let's move along. And bear with me while this lovely thing decides to go nuts on me. There we go. So the first thing I want to take a look at is the application itself that we're going to see as part of the examples. Pretty simple one in most cases, you'll see. Again, this is just the, shall we say, the SQL code. So in working storage, I have 3 includes. The first one is kind of necessary. The include for SQL CA, that's the communications area for your application to communicate status, if you will, or get status back from DB2. The next 2 includes are DCL gens, or output of DCL gens, for the 2 tables that my little application uses. And I have included on the slide one partial set of the output, the important stuff, shall we say. The one include statement for the department table. And as you can see, it's an SQL declare statement to declare the table that we're accessing and all the column names. And the actual COBOL structure that gets brought in and gets used as I start to work with the SQL statements, right? The information coming back or going to DB2. Necessary for program execution. And in my little notes, kind of like the last sentence of the paragraph, I can also do copies as opposed to SQL includes. We tend to use the integrated compiler that translates both the SQL statements and the CICS command level statements at the same time. So we could do the copies, or we can do the includes. So on the next one, I do this, and I typically recommend that these go into working storage. This SQL statement is for the declaring of a cursor. My simple little application is going to do nothing more than a kind of a simple cursor process, you'll see. The important thing is the interface and how this is working, right? So we'll just go from there. Now I tend to tell folks, the declare statement should really be in the tail end of working storage. Kind of gets them out of your normal field of view. They're not executable per se. That's just set up for DB2. Now, again, any SQL statement, and this is pretty simple. It's nothing more than a simple select, but I am pulling based upon a department number that gets entered from the screen, a selection of people that work in a particular department, okay? And of course, being that good programmer that I am, I gotta order those results, so I got the order by salary. Now, in kind of like the last comment on this slide, this is a simple thing. However, 70% of the performance of SQL is really how it's coded. So if this was a much more complex, multi-way join, more than one column on the order by, okay, in this case, you notice I did descending, it could take quite a bit longer. A lot too depends upon the amount of information in the table. Now this particular sample table that we use, it does have quite a few rows. It does have, I think this is the one that has about 50,000 rows in it, but by normal production scheme of things, nowhere near what I know some people have in production. So declare a cursor, and again, the main concern here is how this thing is coded. It really affects the processing. And the order by, I'm gonna sort the result set. So after I select, or after DB2 selects all the information, it's got to sort the results set. Moving on, the other code I have is I do an SQL select to find average and maximum salary. So based upon the department and how many rows are entered within there, it could take a while. Depends. It really depends upon the number of employees in that particular department, because it's got to go through all the rows and compute the average and max salary. Okay. The SQL Open is where the declare cursor actually gets executed. So during the scheme of things, this is where probably going to be one of the highest, shall we say, response items that we're going to see. Because again, it's got to pull in all the rows for the particular department that I enter, and then create the result set and sort it on salary descending. Chances are I don't have an index on salary, so it is going to have to physically do a sort. Fetch. This is actually being done in a loop. So it's in a loop in the program to loop through, pick up, and process all of the results in a result set. My little application does not end until all rows have been retrieved. Now, as I do this, it is producing a little report that'll get displayed on the screen. So it could be 5 people, it could be 20 people in a department. Once all is said and done, as part of the last thing I do is simply close the cursor, which will free up the result set. Okay, so nothing complicated. And again, the mission here is really to give you things to look at about the interface and how it really works. So that's a look at my little code, if you will, and what we're going to start seeing. Now, I chose next to take a look at CICS Trace. I'm a very large proponent of making sure that CICS Trace is turned on. I tweak it, when I deal with CICS system people, system admins, I give them information about how to tweak Trace so it can be used for application profiling, minimizes the overhead of Trace. Okay, so this is part of what I would see was that minimal set of trace options turned on. Okay, but I'm going to focus strictly on the trace entries associated with the Db2 interface. So, enough said. Okay, so let me switch pointers here for a second. All right, so not going to get into the format of trace, but I have bracketed on the left-hand side ERM event, if you will, pardon me, ERM entry, ERM exit. External resource manager, entry, and exit. Entry is when I go to the CICS Db2 interface. Exit is when I return back to the application. So in reality, for the duration of those entries, okay, from that point A to B, if you will, my application, as far as CICS is concerned, is in a wait state. The interface is done on its own TCBs. We'll get that out a little bit later here in the presentation. It's done on its own TCBs. It's done on its own threads, if you will. And once control is given to the interface, it really is consuming time, but more so on behalf of DB2 as opposed to CICS and the application. So the application essentially is waiting for a return. So that's kind of what we're going to see. Now on the right-hand side, however, I highlighted a couple of other entries. D2EX1 entry, D2EX1 exit. That is the point at which CICS physically has gone off to DB2. Okay, and in my case, there's a couple of extra events and interactions because it's got to schedule, if you will, the thread and get some work done. But essentially, this is doing the SQL select statement. So if you ever wanted to really capture how much time you're really spending off in DB2, if you will, as opposed to CICS, that's what I kind of give you on the right-hand side of the slide. Okay, 0.01142 and so on. Okay, I just took the two timestamps and subtracted them, if you will. Okay, the entry from the exit time. Likewise, the time in the interface, a little bit higher, 0.012 on the left-hand side of the screen. And again, that's strictly within the interface, right? So it's interface and DB2 time, however you want to look at it. My application during this process is waiting for a return to come back, okay? Again, got to point this out, the D2EX1, when I give control to DB2, okay, and again, we can actually see kind of like events where it actually is going off to DB2. So it's bouncing back and forth to schedule that thread. Again, we'll talk a bit more too about threads a little bit later here, okay? So, but this time is all considered to be part of DB2, not part of CICS. And it's not until I see the D2EX1 exit entry that I have come back from DB2. So you can see how much time I've actually spent over in DB2 land, if you will. Now I gave you a little comment, the last sentence, if you will, on the slide or on the page you have. Our small little mainframe, right, has executed about 1.5 million instructions at this point. So, give you an idea of what's going on. Okay, moving on a little bit. So now here's the next DB2, and this is the actual SQL Open. So once again, ERM entry, well, I don't even show you the entry, but ERM entry, I cut it off, sorry about that. It'd be right before the event. To ERM exit would be the time in the interface. And once again, D2EX1 entry, D2EX1 exit would be the actual time off into DB2, if you will, to complete the request. Now, so here, a little bit less, 0.0033. And I think I tell you that in reality, we've actually done about 400,000 instructions, right, in the interface at this point. And that includes the time in DB2. So once again, this is the open. Now, that is going to vary. The actual SQL Open here is going to vary primarily because, one second here, somebody's asking a question and I can't see what it is. Okay, somebody's asking about the slides. I gave a link. It's our website, www.themusinc.com. Webinars, you'll see a tab on top, webinars, and there's a thing that says get the presentation or get the slides. And that's where you can find those. Sorry about that. Okay. All right, so back to the slide here. So again, by all means, pull them down, the PDF. I think it's like, there's a couple of cases where it went, like the text went over a page. I've got like 56 slides. It ends up being 59 pages for some reason because of the text formatting took it over by, I think, one line and a couple, 3 slides. So, but you'll get the idea. Okay, so once again, trying to show you, how I can actually tell where I am, how long it takes to accomplish these things. Okay, bear with me here. Okay, so kind of moving on. Now, I did not capture all of the fetches as far as put them on the slide. What I've done is the first one, okay? And again, ERM entry to ERM exit is the time I'm in the interface. My application in CICS is in a wait state. D2 EX1 entry to D2 EX1 exit is the time I've been out there in DB2. So this is the first of the fetches that I did to bring back the row from a result set. So we've gone through the SQL Open, we produced the result set, now I'm pulling back the rows, okay? Not that much of time, 0.0011, right on the right-hand side, but you'll notice it's 0.0038 as far as the whole interface goes. And that's because it's gathering up, shall we say, the interface is gathering up storage and a few other little things that you don't see here going on in trace. I purposely have kind of pulled them out. I was trying to focus on the true DB2 interface entries to try to, again, give you a feel for what's going on. Okay, so it is take a little bit of time. Now I took the timings, right? Again, this would be the left-hand side, the interface timings as opposed to the actual DB2. For the second, third, and fourth fetch, there's only 4 rows in a result set, okay? And you can kind of see the total time, right? Kind of creeps a little bit, if you will. So I just wanted to give you a feel for what's going on. Can't explain why on my system it's creeping a little bit, keeps going up. I take that back. These are the fetch times really from the right-hand side from when I actually go to DB2. So I went 0.0011, 0.0018, 0.0021, 0.0026, and so on. Total time, 0.0105, so on. And I think I put a little comment, that and again, that would be the 5th fetch being done. I had to do a 5th fetch to basically get the indicator that there were no more rows to be found, okay? So finally, I get to my SQL close. And again, time interface, ERM entry, ERM exit, time actually in DB2, DX or D2 EX1 entry to D2 EX1 exit. So the close basically is, as it says, to end the cursor process. So it's all my little application does, right? Did not get any updates, things like that. The timings, again, these are fairly simple queries. Again, I'm just trying to show you the mechanics of how to look at this stuff and how to kind of determine what's going on, okay, as opposed to, you know, real performance tuning. Because again, our system is quite smaller than I'm sure a lot of yours are, and performance really is based upon the, you know, system that you have, you know, a ton of things. So this is more about the mechanics and how to look at it from your point of view, if you will. Okay. One last trip into trace. And that's what happens during CICS return. So my little application has done a CICS command level return, okay? And again, I've pulled out a bunch of trace entries. Wanted to focus on the interaction of the DB2. So connector A here, and again, I'm pulling from the notice the RMUO entry to RMUO exit. Within CICS trace, there's always going to be a corresponding entry and exits. Okay, so you know exactly where you are, exactly what's going on. So that's the time, and if you'll notice the comment, we're going to commit the unit of work. Now, there's not a lot of need, or shall we say, a lot of things that need to be committed. I have not done any updates. I have done read only. So it really is going to do only a single phase commit, and we'll actually see that down here, okay, in the trace. And that's because I've done read only. I have not done any actual changes. Had we done the changes,
or had I done inserts or updates or deletes, then we would see a two-phase commit being done. Okay, CICS is the coordinator. You do not do DB2 commits. You do the SQL, or you do the CICS equivalent, which is a sync point command. Most applications do not do sync points. However, one is automatically done as part of the return. So if the application has not done a sync point during the return, it's going to do one, which means it will commit with DB2. Okay. Now, so point A is the total time interacting between the interface and DB2 to accomplish the single phase commit. Okay. Hold on here, I'm getting questions. Okay, it's still the same one. Okay. All right. Point B, okay, or connector B, is going off in reality to RRS, Resource Recovery Services, on the mainframe. That is the, shall we say, sync point coordinator for both CICS and DB2. Okay, so I went ahead and captured the time spent there. Still considered part of the interface. And then last but not least would be the actual time. Again, at connector C, you'll see the D2EX1 entry, DB2EX1 exit. So there's the actual time over in DB2 to accomplish the commit. And I didn't calculate the times. Okay, I'm sure you can do that pretty easily with the, looking at the trace timings, what I bolded. Again, it is a single phase commit. So that's going to be a little bit less time than doing a two-phase commit, right? Because of the updates and that being done. Needed, again, just wanted to show you the mechanics as opposed to real timings, because my system's a lot smaller than yours. So those are kind of things you're going to see in trace. And again, you will definitely see exactly when you're in DB2 versus in CICS. And again, these ERM entries that I'm kind of highlighting as I went through, that's when you're in the interface. So the application is waiting. Within the CICS region itself, that application is asleep, doing nothing while you're in the interface. Okay. And again, these EX1, D2EX1 entries, you are truly off in DB2. It's over in DB2 region. Okay. All right. Quick look. CICS provides a simplistic debugger, CEDF, right, to debug things. It does work with SQL statements. So I just wanted to, quickly go through this and highlight a couple things to you as we do this, simply because it can be useful as you start to work with debugging applications, or as people do that. Okay, so moving right along. Now, the way this works, if you kind of get the idea of the trace entries I went through, the entry and exit, well, here we're going to see about to execute command and command execution complete. You'll see on the next slide. So again, we stop before we do the command. Now, it does show me the basic statement, a select. It does show me the statement number tied back to my COBOL program. Okay. And if there are any variables in use, in my case, right, this is the select, and I had a where clause. This is to find the average salary and the maximum salary for a department. So I had a where clause for the department number, and you can see input variable 1, right? And there's the actual thing. Now IBM only shows it to us in hex. So Charlie 3 is a C, F0 is a 0, and F1 is a 1. So C01 is the department number I entered. It is a character field, length of 3. Okay. So I can see most of the information about what I've done coding-wise for the SQL.
And again, next slide, command execution complete. So here we see it's done. Now, once again, I get the basic SQL select statement. It does tell me the authorization ID, in this case, user ID. Now, we have test regions. I don't make people sign on. In reality, I've turned off security in our test regions. So basically, that's the default CICS user in our case. But I don't really make people sign on. Now, upon completing, I want you to notice, here's the first variable coming back. There are basically two variables coming back: average salary, maximum salary. It's all I'm pulling back. But if you notice the little plus sign, I can expand it, and I actually see all the variables. It does not give me the column names that I've coded, but they are presented in the sequence that I've coded them on the select, and I can see the actual data coming back. Okay? So that is, right, what you can see, if you will. Okay? The other kind of important thing here is I can tell how my commands have worked. SQL code of 0. So it's showing me the SQL CA and pretty much the entire SQL CA. Okay? So I can see how the commands are being done. And once again, right, the statement number. So moving on to the next one, this is my SQL Open, statement number, and again, any data I pass, Charlie01. The cursor process needs to know the department number to perform the select on. So pretty much simple. And again, command execution complete for the SQL Open statement. And again, I can now see the SQL CA. Now, there is no data coming back on the SQL Open statement because it's basically producing a result set. There's no information to pull back. And again, the SQL code is a 0, so we can see that it has gone successful or worked successfully. So about to do a command, in this case, the fetch, statement 498, my little program, okay? And of course, command execution complete, fetch, and once again, I can see my data variables. Please notice the plus sign. I can expand and see them all. Don't have column names, it's just the way the CDF shows it to me. It shows me the data. Just calls them output variables, OVAR 1 through whatever, however many columns you've coded on the fetch. Okay, it brings them back and shows me the actual data. Unfortunately, only in hex. Sometimes I wish it would show me the character. Makes it a little bit easier to read. Okay, and again, the SQL code of how it works. Okay. Did not bother capturing, well, I take that back, did I? I captured the last fetch. So this is a fetch, same statement. Remember, this isn't a loop, right? 498. But this one here is a little different. So on completion of the fetch, please notice the plus 100. Now, the data is left over, so you got to kind of be careful, right? In this case, the data doesn't matter because it's left over from the previous fetch. But the plus 100 basically says I've processed all the rows in the result set. So I've done 5 fetches. This would be the number 5. First 4 return data. This one returned basically the fact that I've hit the end. Okay. Then we do the SQL close, statement 536. And of course, it completes normal. SQL code of 0. So I can, right, use this simple debugger. Now, we also have IBM's debug tool far more complex. But this is CEDF, part of CICS, and it works great if all you want to do is step through and make sure your applications are working and doing what you think they're doing. And I can't see the commands. I don't see the complete SQL command syntax, but I do see what the command basically is. And I can see the input-output data areas, right? And it does tie me straight back. So if I got my compile list, I can tell, right, by looking at the compile list where I am, okay? All right, I wrestled with how I do some of this. I decided I'll show you the statistics before I get in the actual, shall we say, configuration of stuff in the interface, okay? Again, not trying to go into any kind of tuning here. I'm really trying to do nothing more than highlight some things for you to look at. I've only got an hour, and we've gone through half of it already. Now, IBM supplies with CICS a transaction called DSNC. And what I've done here is a DSNC space stat. And this is give me the statistics from the interface point of view, right? As I'm doing all my calls, as I'm doing all the interfaces, right, it's counting things. And some of that can be quite useful to us. Right off the bat, we can see there's my name of my CICS, or DB2 region rather, right? DB1A. This happens to be a version 11 DB2 region we're using. I'll explain more about this in a little bit, but we have 3 different types of threads. Like I said, I wrestled with how I wanted to do this. We'll talk about threads in a few slides here when I get into more of the configuration. Command thread is doing DSNC transaction. Pull thread, I'll get into what that is, but it's for threads where you do not have particular transactions associated with entries. And the entries are then shown. In my case, I only have the one, THMZENT. That's a resource I defined. And again, I'll get into all that. Now, so these are the things. Now, if you had multiple DB2 entries defined, you would see them all here. One entry for command, one entry for the pull, okay? And of course, the plans associated with them. Now, this is the default plan kind of used between CICS and DB2. You really have to work with your system admins or DBAs in DB2, if you're the CICS guy, to make sure this is done, you know, that's the plan name. This happens to be the default one that's good enough for us. However, this is the one we set up, CICS PL, for working with applications in CICS. So as I'm doing CICS and doing applications that are doing DB2 requests, that's the plan that's used, right, for our classes. So quickly, so number of calls, not many, 7. Number of authorizations, 0. Now, I have security turned off, so that's why I have no authorizations. But basically, if I had it turned on, we would see the number of times I have to authenticate, right, or authorize the connection to DB2. We'll talk a bit more about that when I get a configuration, because that's a concern. In the case of the pull threads, I don't have anything going through the pull, but the pull threads are not what's known as protected, and I'll explain that again. I'll get to that in a minute. The pull threads are not protected, so basically almost every time I use a thread, I have to authenticate. I have to do authorization, extra overhead, and that's going to be explained a little bit later. The WP column here is wait or switch to the pull, okay? It's an indication of the number of times that I've had to either make an application wait because there's no threads available, or I went to the pull from an entry like THMZENT, okay? And again, I don't have a lot of activity going on, but I could see that. Now, again, indication I may not have enough threads is what I'm driving at here. Now that's the kind of current, if you will. This is the high watermark of threads in use. Okay, so I haven't used, right, a lot of threads. In my case, very simple. So the W/P column is waits occurring, right, because I don't have enough threads or had to go to the pool, okay? And I don't recommend going to the pool, you'll see. And the high is the high watermark of number of threads used. In this case, for the entry, only one. And again, we'll see some of these things. If there has been any aborts from DB2's point of view, in other words, I've tried to do something and DB2 abandoned it, right, the task. So I've had to abandon it, or it had to be abandoned in the Db2 interface, and I've had no aborts. And then we get the number of one and two phase commits. I've only had the one phase commit simply because I did only read only. Okay, so some general statistics from the interface point of view. Okay, now these are the actual CICS statistics that are coming out on what's the interval for statistics or the end of day, if you will. I'm not going to get into a lot of this. This is all from the point of view of dispatcher. It's like only one small portion of the statistics. And all I'm really highlighting here in my notes is the L8, L9s. Those are the TCBs that are used for the interface. They're used for other things. They are used for what's known as a external resource manager. ERM stands for external resource manager. So it's not just DB2. It could be MQ. It could be other databases that have external resource managers plugged into CICS. But from our point of view, talking about DB2, these would be the TCBs where it's done. The difference between the L8, L9, if you're not a CICS person, in CICS, I can define my applications as running in what's called execution key of user or CICS. It relates to the storage protect keys, right? 9 is user, 8 is CICS. So the L9s is things running in user mode. The L8s are things running in CICS mode. Now the interface is really doing things in CICS mode. My application could still be in thing. Now my application actually was in quasi-reentrant mode. These were not defined as thread safe when I ran them. So my application is reflected up on this QR. So the interface is running from CICS point of view in CICS mode. Okay. Just want to give you some timings, or where this shows you the amount of time total spent in the interface, if you will. Again, you got to be careful. It could include MQ time. In my case, it doesn't, but it could. So another part of the statistics is the actual DB2 connection. Tons of information up front. Again, here's my region name. Here's a version, 11.1 in our case. It is connected, okay? The plan name used for the pool. Now I can do a plan exit. I'll briefly mention that at the end of the configuration part, okay? Dynamic plan exit, I should say, okay? Now we've chosen to define a plan. I can't give you a recommendation one way or the other. It really is environment specific, okay? We're obviously doing a lot of training. We can define plans. We don't care about splitting out statistics by different DB2 applications. By doing dynamic plan exits, we are changing plan names based upon the application. So I could better account for what's going on for each application. Okay. Again, authorization would be user ID if I had security turned on. Transient data destination, CDB2, is the IBM default one, but basically as the interface is putting out messages, things that are going on, they're going to go to that transient data destination, okay? you could see some things like if threads get canceled, if aborts happen, and then CICS interface has to roll back because of DB2 minus 911 or something, you could see messages coming up, okay? We'll talk about the priority here equal. The default is high. I don't like that. Configuration limit, I told it the maximum number of concurrent threads in DB2 is 8, right? Peak has only been 1, okay? And if I've got tasks waiting for threads, they're waiting on this ready queue. So the number here could be important to me, kind of indicating I don't have enough threads, okay? Again, I'm trying to not do total tuning. I'm trying to give you a lot of information in a very short period of time. This is actually continued on, it's like page 2, if you will. So it does tell me the thread limit on the pool, but notice it says peak number of threads, right, and number of waits. Again, didn't do much, right, but you can get the idea what to look for. So that's telling me the number of threads I've used, right? If I'm at 3, then I might see the number of waits might be 10. Maybe I need more threads. Okay, current number is currently 0, and of course, statistics on the ready queue, and once again, task on the ready queue is telling me these are applications that are waiting for threads, waiting for access to DB2. Not too worried about the command thread. It's 1. I don't know that you're going to have multiple CICS administrators doing DSNZ commands, so I chose to put the command thread at 1. Okay, if you had 10 system programmers trying to do DSNCs, you might want it to raise the bar. I don't know. Got to be careful with the number of threads. Get to that in a minute. Okay, last part of statistics. This is for my entry. So this is for my entry I did. Again, we have a static plan. I could have a dynamic plan, okay? If I'm going to run out of threads, I want to wait rather than go over to the pool. I'm trying to minimize the overhead of the interface. By going over the pool, I lose what's called a protected thread. Again, let me get to that when I get to configuration. Again, equal. So I've only done threads for 3. Now, this is a particular entry, which is related to a specific set of transactions. In the real world, you'll probably have dozens of DB2 entries for your different applications. And you'll kind of consume the resources based upon that. Of course, only one's in use, my little test transaction that I did. But I am looking at things like current number of protected threads, right, peak number, and so on. I've only got 1, so out of 3 threads, 1 is protected, okay? Give you kind of an idea here in a second what that might mean to us. And again, current number of DB2 tasks, right, peak was only 1 that I did. And of course, if I have more than some on that ready queue, I probably don't have enough threads. I need to make things, maybe make adjustments. Now, protected threads is basically saying I want to keep that thread for the duration of the application. In other words, till it does a return and commits, okay? So if I got a highly active transaction, it minimizes the overhead. If you kind of look, here's the number of calls, but if I was not running on a protected thread, or if I was like running on a pool, I would start to see sign-ons being done, creation of threads, thread terminates. That is adding overhead to the whole process, okay? And I think on one page I said somewhere, maybe it's coming up in the configuration, it can be 4 to 7% extra overhead. So you really want to create DB2 entries for your specific application transactions and consider if any of them are high use, you really want them to have protected threads to minimize this overhead in this interface. It does matter, especially if you're paying based upon CPU utilization. So those are statistics that I typically look at. And again, I would have different entries for my different applications. Okay, resource definitions. So a quick overview. So in the CICS region, these are what's known as task-related user exits or TRUs. So the interface is, right, this thing. Now, these TCBs are those L8s and L9s. And again, we have command threads, pool threads, entry threads. The command thread is strictly for the DSNC transaction. And again, I'm not sure that you need more than one. Pool threads are all accesses for applications doing SQL requests that you do not have a specific DB2 entry for. If I don't have a transaction defined into a DB2 entry, then it's going to use the pool. Pool threads cannot be protected. Every time the threads are used, they're going to go through some kind of partial sign-on. It depends upon was the thread used by the same application or not. If it was not, it's got to do a sign-on because it's going to be potentially a different application, different user ID. Okay, it may also have to create and terminate the thread. It all depends. So again, pools are not something that you really want heavily used. So you want entries, right? It is multi-threaded. And again, plans are going to have to be worked out with your DBAs or sysadmins, whoever sets up plans in DB2. Okay. So here's the DB2 connection definition. So as a CICS systems person, I have to define it. Now, my connection name is the same as the subsystem name that I've defined. Okay. The actual subsystem name is provided by a system parm at startup, SI parm. Okay. But I've actually defined my connection with the same name. Keeps me sane. TCB limit, the maximum number of threads, command, pull, and entry threads allowable to be consumed by this interface. Now I tell you in my notes, it cannot be equal to or greater than a CICS SI parm called max open TCBs. Max open TCBs is the maximum number of TCBs for the L8s and L9s. If you are at the limit or above, you're going to see some messages at startup that say you can never use all these TCBs. In other words, if I said TCB limit of 50, but my max open TCBs was only 40, I'm going to get an error. Well, I shouldn't say that, a warning at startup. And DB2 would never be able to use more than 40. But please remember, the interface is also being used for things like MQ and a few other things. So you do not want DB2 consuming all of the TCBs because you could potentially harm other accesses. Okay, so that is the maximum number of allowable threads in DB2. It's done on a connection entry, but this is a purge cycle for protected threads. Now I showed you a protected thread. If that thread has been allocated to an application, but has been inactive, in this case for 30 seconds, that's what the 30 is, it's minutes and seconds, it can release the thread for another application. For the connection, I've defined this user ID. Again, this is my general thing, but we may want a specific user ID to establish connection. Now, this is not a user ID that would be associated with an application. This is basically so I can authenticate when CICS tries to connect to the DB2 region, I can have specific security rules set up. Consider it to be the region authenticating itself to DB2. So you might have a special user ID. Command thread of 1, right? So again, I probably don't need any more than 1. Plan name for the pool, thread limit for the pool, 3. And I said equal priority. And forget the little typo there on the thing here. I said 4 here, it's really 3. Now, here's the deal. So default is high. That says all the TCBs for the pool are higher priority than CICS's own TCBs. Not so sure I like that. could potentially cause undue harm in CICS, especially if I have highly active DB2 transactions, okay? Equal says they're going to run with equal priority, right? And it's going to be workload manager that's going to do the, shall we say, juggling act, okay? To me, that's far better than doing high. High is the default. I would never code low, whether lower than CICS's own TCBs. But I've taken 1 for the command, 3 for the threads. So out of the total of 8, I'm allowing 4 here to be used, right? Okay. Second slide for DB2 command, because I had text that went beyond, right? So DB2 entry. So here's my entry. Again, for any transactions that begin THMZ, the asterisk's a wildcard. Transaction codes are only 4 characters. This is a wildcard. So THMZ says all the ones begin with THMZ. Asterisk says anything. And I could put the asterisk anywhere, right? Again, the plan, I'm using static plans as opposed to dynamic plans. At the end of the configuration here, I'll kind of give you a hint. Protected threads 1, thread limits 2. So I'm allowing 2 threads for this entry. That says that this application, whatever it is, or set of applications, I will never have more than 2 concurrently making requests to DB2. One of those threads will be protected, which says that one of the transactions in this being used here is highly used DB2, a lot of DB2 requests. You know, cursor fetching, right? If I got a application that's fetching many rows out of a table, out of a result set, it's a highly used application for when it's running. So I may want that protected thread. Minimize that, other things that go on like creation of thread, termination of thread, etc. It's about 4 to 7% extra overhead to do all that. So I want to protect the thread as much as I can. Okay. So basically that, now notice this would be 2. So 4 for the command, between the command and pull 4, 2 here. So I could have another entry that would have 2 threads, right, before I hit the limit of 8. Now, I got to caution you. I can have DB2 entries that add up greater than the TCB limit. Let me back up. So even though this is 8, all my entries could add up to be greater than 8. The real question is, when are they in use? I can never have more than 8 in use at any point in time. And out of that, 4 would be reserved for the command and pull. Okay, so you get an idea how this works. So you really want to be, careful about how you allocate your threads in that. If you go over the limit of 8, thread limit of 8, not a problem. The question is, when are they being used? But this particular entry, this particular set of applications, I can never do more than 2 concurrent requests for any transaction begins THMZ. Okay. Again, second entry slide, because I went to text, definitely had to go over. DB2 Tran. Sometimes you don't have a good pattern for all of your transactions. So I give it an extra entry, I relate it to that entry, THMZ entry 1, and then I say THM plus sign. So into that same grouping, if you will, I'm going to include any transactions that begin with THM. Now the plus sign here is a single character. Well, there's only 4 characters in a transcode, right? But I wanted to give you examples of, it could use the asterisk, which could be multiple characters substitution, or the plus sign, which would be single character substitution. So this particular DB2 entry, THMZ-ENT1, would affect all transactions that begin with THMZ or THM, or THZ rather, or THM, okay? And again, you can have many DB2 trans associated with the same entry. So you can list out all the transactions that become part of that entry. And you're better off doing that to get all of your transactions associated with a particular DB2 entry and control the usage of threads and protected threads that way. Again, avoid the pool, especially in production. Now, as I said, I would show you about a dynamic plan exit. Well, this is a very brief extraction. IBM provides a sample. It's in the SDFH SAMP library. It's called DFH D2 PXT. It is assembler code. Has to be assembler code, okay, because of the way it runs. And I just showed you the comments in there where you would put your own code. So dynamic plan exits, I have coded on the pool and on the entry specific plans. It will never use a different plan. Now on the pool, that may not be practical, especially if you want to account for different applications from DB2's point of view. You would have to have different plans for the different applications. So you would have to do dynamic plan switching. Now I got to caution you, if you do that, you are negating the effect of protected threads in the entry. You are going to force constant sign-ons, right? Creation and termination of threads in the pool threads. So you're going to be adding overhead. So for the sake of keeping accounting straight from a DB2 perspective, you are causing more overhead in the interface, right? Because you're switching plans. And as you switch plans, it's got to recreate the threads because of the different plan. It's got to go through sign-on to DB2 for the authentication and so on, right, to a different plan. So that's both overhead in the interface and in DB2. Okay, so, right, that's the dynamic plan. I didn't show you a code. I talked a bit more about it in our CICS customization class, but I wanted to give you some insight as to what a dynamic plan was. Okay? One last little piece I'm going to cover, and I'm going to run a little bit over. Sorry about that. Dump, system dump. Now, if I happen to have a dump for whatever reason, okay, in this case I requested one, I want to give you some information about what you're going to find in a dump, CICS dump, okay? So I've asked for the format out the DB2 information, right? Both summary and data areas. So I get the information about, my DB2 region, right? Name of the region, what the version is, and so on, kind of like you saw in the statistics. So here's a transaction that's actually in the system, THM or THZY. It is transaction number 300. Now, of all this stuff, if I had multiple transactions that had done DB2 requests, they would all show here. In the real world, there could be hundreds here, okay? What's important besides tran ID and task number, name of the entry, the DB2 entry they're associated with, and this little guy right here, correlation ID. If you need to cancel a particular thread, let's say you took a dump and this thing is just constantly running, the same application, it's not ending, you want to cancel the thread. You can cancel it from CICS's point of view with the commands I'll show you here in a little bit here. Sorry, I'm going to run over. But you need the correlation ID. That's how you got to cancel the thread. You can't just use transaction ID and transaction number. You must use the correlation ID. Out here, basically it says at the time of the dump, this transaction was over in DB2. That's what the yes simply says. Okay. Now that's the summary. That's all there is. But if all the transactions, it would show me all the transactions are current state. I only had the one. In the data areas, now I got to caution you, these are not documented. IBM dropped this thing called the supplementary data areas with CICS TS 4.1. The good news, these data areas really haven't changed. So in my notes, I kind of give you, right, there's something called the life of task block. This is for my transaction. I can see my plan, okay? I'm giving you a bunch of information. Here's the authorization IDs, primary and secondary auth IDs, okay? So I give you some information about the format, right? Because it really hasn't changed. This other data area called the C sub, right? the subtask control block associated with it. The lot is life of task. So it's the basic information on the summary that I just showed you, but in a data area, okay? The C sub has same kind of information, and I give you some. You can see here's that thread ID, or that correlation ID, primary, secondary auth users. There's this little trace. And if you kind of go to the second page, where I lay out the bigger C sub data area completely, I give you some information about what you might find that little trace. Mine's not too exciting, but you know, API means it's just the API type calls. It's not something I can control. I can't control the size. It's just the interface has blindly set up this little internal trace. I do tell you the format of the areas, right? They're only hex, they're 16 bytes each, okay? And you can kind of see some things. So could tell you a little story, depending upon what the situation is. Okay, one of the other summaries is dispatcher summary. And all I've highlighted is things. Now, this transaction is active. The A is saying it's running, so it's actually running and it's active. It's my task number 300, okay? But what I wanted to show you is if there was a wait state, it would show in these columns. If you did a CEMT, now I did not have this thing, you know, at the same time. Apologize for that. I did not do a CEMT when the task was running. But there would be the wait states shown there, okay? Now, I'm not going to go through the next few slides. What I've done is pay attention to the text. I've given you a bunch of things that you might see in the wait states, right? Either in the dump for dispatcher or within the summary, or the CMT, the wait states. So I'm not going to go through all that. I want to give you some information. You can kind of read it yourself. More DSNC commands and we'll be done. Now, I can also display threads from a DB2 point of view. So basically, this is the DB2 display threads. You can see the status. I've kind of highlighted that, the ST column, okay? I promise I'm almost done, guys. I tell you what all the statuses are, a whole bunch of them. I'm not going to read them to you. I've also highlighted the correlation ID from this display. So if I wanted to cancel the thread, there's a correlation ID I can use. You have to implement something called BMS paging commands. They're done by CICS SI parms. And P/N is to go to the next, P/P would go to previous. Those are things you have to code in SI parms. This could be a multi-page display. You cannot use F7 or F8 because the way this is done is through what's called BMS page build, the way that the internal interface does that. So you could page forward or backward with those commands, okay? I've done a display database command. This is definitely multiple screens. So once again, I have P/N for the next, P/P. And all I gotta do is put the cursor up on the very corner up there and key that in and it'll go. So this is just telling me the status of a database, right? And if I go on, here's page 2, okay? Again, I did P/N to get here. So I can do the DSNC command besides the stats, right? There's not much I can see. You know, if I do a DSNC, I can display threads from a DSNC point of view, or pardon me, and then I can do it from a DB2 point of view, and then I can do the any other DB2 command. Display database statuses, I can start, stop databases, and so on, okay? DSNC transaction, right? Disconnect says disconnect the plan name. Basically, kind of puts the plan into a wait state. So I can prevent a certain application from processing. They would just get the fact that the plan has been, put into a status where it can't be used. DSNC stop to stop the interface. DSNC start, STRT. Now notice I can actually stop the interface and start to a different one, right? I can specify a whole different DB2. I can only have one DB2, subsystem associated with the CICS region at any point in time. But I can switch if I want to by stopping one. CICS says, again, there's a force. I don't want to get into that, but I can do a stop CICS that says allow all the applications to terminate gracefully before you physically stop the interface, right? So I could switch at that point, okay? Cancel threads token is that correlation ID, okay? So I use that to cancel a thread, and I can start and stop databases or table spaces, getting into more of the DB2 commands, right? So if you're DBA, I'm sure these are second nature to you, but I could, from a CICS point of view, do the DSNC commands transaction to do those things. Obviously, the DSNC transaction is not something that you would want applications using, okay? Now, I'm not going to get into the rest of this. I included the complete CEDA resource descriptions. When I showed you defining DB2 connection, DB2 entries, DB2 trans, I showed you the basic parameters that work, right, and what you need to worry about. I have included the complete definitions, okay? Screens, which you would see if you did it online. As kind of like a little thing. So that's it. You've got my email if you've downloaded the presentation. If you've got questions, by all means, please pass them along. I hope that I've given you some useful information about this interface. A lot of information in a short period of time. I'm 7 minutes over, and I apologize for that, folks. But have a good one, and go ahead and knock off and go have your lunch. Thanks for attending.